Hi, folks. We're going to take a look at number 11, part C and D from the Unit 6 assignment. So they give us function f, which is given as sine of pi x, and they want us to estimate the instantaneous rate of change at x equals 2, and then in D at x equals 0. All right. So what I'm going to do is I'm going to use our established convention of going 0.01 away from the given x value to estimate an instantaneous rate of change. Okay. So the instantaneous rate of change, of course, is given by the slope of the tangent to the function at x equals 2. But since I can't find that exactly, I'm going to approximate it by finding the slope of the secant, which joins x equals 2 and x equals. So I'm going to go 0.01 above, so it's going to be 2.01. I could also go to the left-hand side and use 1.98. Okay, and if I wanted a better approximation, I would just use a number even closer to 2 as my second point. All right, so what I'm going to use here is I'm going to use f at 2.01 minus f at 2. So that's going to be my difference in my y's, my y2 minus y1 over x2 minus x1, okay, which is going to be 2.01 minus 2. All right, so essentially this is just the slope of the secant line, which joins the point at 2 and the point at 2.01, which is very close by. All right, so what I'm going to do to save myself from doing a whole bunch of estimating, as I'm just going to try to put everything into my calculator all at once. All right, so here we'll start with a sine of 2.01 times pi. Okay, I'm just replacing x by 2.01. All right, close brackets, minus sine at 2 times pi, although you should know what sine of 2 times pi is equal to. All right, and now I'm going to divide that by 2.01 minus 2 is, of course, just 0.01, and we get 3.14. Okay, interesting answer. Okay, so that's our approximation for the instantaneous rate of change. All right. Now, if you were to repeat this whole process for x equals 0, okay, let's do it here. If I do it, so this is C and this is D. Okay, so again, this would be, well, this is approximation. Okay, 0 plus 0.01, so I'm going to take f at 0.01, okay, minus f at 0 divided by 0.01 minus 0. Okay, and let's see what that gives us. Okay, so here we've got in the numerator sine of 0.01 times pi, and then minus sine of, well, 0 times pi, sine of 0, which of course you should know exactly what that's equal to. Okay, and then divided by 0.01, and hey, there you go, exactly 3.14 again. All right, so the question is does this make sense? Well, let's take a look at this function here, sine of pi x. Well, I see that the period of this function is going to be, well, 2 pi over the k value. So I see that the period is equal to 2. So if I were to graph this function here, okay, well, 0, 1, 2, this would be the period. So if I were to graph this here, of course, what would I get? I get this function here, and we see that this is exactly where it repeats itself. So it seems to make perfect sense that whatever the slope of the tangent is at 0 should be exactly the same as the slope of the tangent at 2. And so not surprisingly, my estimates are pretty much exactly the same. All right, so just to recap how we find instantaneous rates of change. So if I'm trying to find an instantaneous rate of change at some given x value, I choose another x value very close by. So the convention we're going to use is you're going to be 0.01 away, either above or below. And then you use those 2 points to find the slope of the secant, which joins those 2 points. All right, and then that acts as your approximation. If you want a more accurate approximation, you go even closer. You take 2.001 or 2.0001, as close as you want to go. All right, that's it for this one.